running, let me know. Okay. So mostly everybody could come to consensus on most of these. The big bugaboo was number 6 for everybody, and particularly 32 to the negative 2/5 power. That's always the most difficult part for students when they come into 107, either remembering it or probably was difficult for you also in 096 if you took 096 here. That's a little tough one. What was the other one that we have to go over? Oh, this one should say to the 4th here. Okay. What other one did you want to go over? All of them. Okay. Well, you guys did fine. The first one, no. Some people multiplied the exponents there. No, so it's, you know, but I think after talking about this, we agreed that when you multiply, you add your exponents, so that should be x to the 7th. I don't think anybody missed number 2. Do I have to go over that? You multiply by 1,000, you move it 3 places. So I agree with that one. Now this one is really an important one to look at because people often confuse with either radicals or exponents. Radicals can be written as exponents. So what I say about radicals and what I say about exponents, it's the same. Okay. Exponents is a way to repeatedly multiply. All your exponent properties apply to multiplication. And because division can be written as multiplication, multiplying by the reciprocal, exponent rules apply to division as well. Anytime you see an exponent and the base, whether it's in parentheses, and you see an adding and subtraction sign, the exponent rules do not come into play as they do like with multiplication. For example, if you just saw 4x squared as your base, and I put a 2 up there, then you can use your exponent property because all you see in here is multiplication. And this 2 applies itself to the 4, and that 2 applies itself to the x squared. These things are called factors. If it was 4 divided by x squared, then the square would apply itself to the numerator 4 and to the denominator. But this is subtraction, and there could even be addition. The same is going to be true. Exponent rules, in terms of applying exponent rules, do not apply to this except for the definition of what it means to be an exponent. So when you see adding and subtracting in there, this is one of the hardest misconceptions to break. If you've been squaring binomials and just squaring the 4x squared and just squaring the -1, it's really hard to break this concept. But I'm just going to ask you, if you're one of the people that thinks this is 16x to the 4th plus 1 because that's the way you've always been doing it, just write out like 4 or 5 of these for yourself and just do them. Do a couple a day to break your misconception because it's really hard to do. But all you use here is the idea of what does it mean to square something. And you see here that you now have a situation where you have to use your distributive property twice, and that's called FOIL. We do this every time we multiply a 2-digit number by a 2-digit number. It's exactly the same. If I wrote this on the board, 25 times 30, let me do 24. 24 times 32, this is the same as 20 plus 4 and 30 plus 2. So if I wrote this horizontally instead of vertically, it looks just like we have up there. It's 2 things times 2 things. And when you do this with FOIL, that's exactly what you do in this little algorithm you learned in elementary school. You do this one times that one, 2 times 4, 2 times 20. That's the 2 times the 20. And the reason you put the 4 there is it's actually in the tens place. Right? And then you do 30 times 4. And that's why you move in. Because you really get 120. And then you get your 700 there. And then you add like things. The same thing happens with FOIL. So when you do this one, you have to do 4x squared times 4x squared, which I agree gives you that 16x to the 4th. I purposely did this to try to catch this. And then you have to do the 4x squared times the -1, which is minus 4x squared. Then it's -1's turn to multiply both this and then -1 times -1 is +1. You get to combine these because these are like x, you have x squares, so it's 16x to the 4th minus 8x squared plus 1. Okay, so that's a little one that's tricky as well. This is adding. This is multiplying. So 7 kind of takes care of the misconception about number 3. This says you've got 21 of these things called square roots of 2. And guess what? You got 10 more of them. So if you can imagine all these square roots of 2 floating around the classroom, it's just asking, how many do I have? Put them together if they're like. And they are like. They're square roots of 2's. So the answer is 31 square root of 2. Okay, 6 is the big one, so let's talk about this. I agree. I don't agree with this. What did we come up with? -1x plus 12, right? This one we had to go backwards to see it. If you multiply 50 by 6, the equal sign goes both ways. You get the square root of 100 times the square root of 3, which is that. So I agree with that. I agree with this. But this is the bugaboo that all students have problems with in both classes. And I guarantee it will even happen in the 1 o'clock class that Caitlin has. Okay, so notice it says section P2 and P3 beside this. P2 does the basic exponent rules for you. And one of the basic laws or rules of exponents is that anything except for 0 raised to the 0 power has a definition. It's 1. It's not something you're going to intuit in your soul. It's just 1. So that's 1. Now this thing here, 32 to the -2/5. I was telling group 2 that this time of year we harvest potatoes, carrots, beets, a lot of root crops. People put their roots in the cellar. They store them in the cellar. Guess where the root goes? The root goes in the cellar, the denominator. So this tells you to take the 5th root of 32, then square it. And then this has nothing to do with the sign of the number. It just tells you to flip it, take the reciprocal. It doesn't matter what order you do it. I tend, when the base is a whole number, I always do the root first to make the number smaller. If the base happens to be a fraction, I usually flip it first. Okay, so in the order, this is what I'm going to do. I'm going to take the 5th root first, which is the 1/5 power. Then I'll apply what's left, the 2 in the numerator and that negative sign. So the 5th root of 32 is 2. And then all I have left to do is this, square it and flip it. Squaring 2 is 4, and then flipping it is 1/4. So this becomes 1/4, and when I subtract 1/4 from 1, I get 3/4. Okay, and that's the answer. So this will probably be the section many of you will want to get a little more review on. All right? And I'll see you all on Friday. Have a great couple of days. Video